Now, measurement of uncertainty, and I'll spend a little bit of time on measurement of uncertainty because it is now being made compulsory for all laboratories to report measurement of uncertainty on microbiology reports. We've been the last place to ever have had to do it, and NATA has now enforced all laboratories to do it. They must do it if they know you are using their results to compare to any guideline, whether it's your own internal or an Australian or international code. So once you tell the laboratory that, they are required to report the measurement of uncertainty. And in fact, you should right now be telling your laboratory who's doing, if they are doing your testing, that you want measurement of uncertainty on all reports. Okay, measurement of uncertainty, every test that's done is subject to some degree of I guess, uncertainty. That can come from a variety of sources. There's pipetting, there's different technicians and scientists' technique in weighing, the inaccuracy of a balance where we weigh the sample, although they're all controlled, they're not absolutely perfect. It's a 0.01 or variation. All of that is add up together, so you'll get a variation, and that's called the uncertainty of that final result. And we can go through, and we have to go through for all of our different types of analyses. Basically, we take an identical sample, be that water or food or surface swabs or whatever. We give identical samples to two different staff members and get them to run through the whole process, and we read the results. We have to do that multiple times on different days, on different time shifts, different times of the day, different combinations of staff, so that we look at those results over that total period and we statistically work out what that variation is for that particular type of test. And we've had to do it for all of our different types of tests. And so it's every other lab. There's no difference. All NATA accredited labs are required to determine the measurement of uncertainty for quantitative, for count analyses. There's no requirements at the present time, and I doubt whether there ever will be, requirements to do measurement of uncertainty for presence-absence type testing. It's either there or it's not there. It's not a necessarily measurement of uncertainty. It could be done, but then it's just going to be so low that it's probably not going to be warrant any, to be interpreted. ISO 17025 is what all accredited laboratories must conform with. In that it states that test reports shall include information regarding measurement uncertainty when a customer instructs the laboratory to provide the information when it's relevant to the validity or application of test results, or most importantly, when it affects compliance to a specific limit. If you tell the laboratory you want it, they have to give it. If the laboratory knows you're comparing something to the Australian Food Standards Code or the Recreational Water Standards or the NHMRC pool and spa guidelines, the laboratory must report MU on all those results. Measurement, and what it is measurement of uncertainty affects the range where the true result really lies, and often it's around about 95%. It's a different figure for each different type of test within a laboratory, and it differs between laboratory for the different style of tests, but it shouldn't be greatly different from one laboratory to another. So if I'm doing a spread plate to get a plate count, as compared to doing a pour plate where you put the bug on an empty petri dish and you pour molten agar on it and let it to set. Each of those tests have got varying different measurement of uncertainty values. Okay? And at the moment, this is just so confusing for you, and I'm going to try and clean it up pretty much right now. Let's presume a specific test and sample we got a result of 50, and this had an MU range of 39 to 64. which is actually how it would come out of my laboratory. Basically, this means if we tested that same sample 100 times, 95 times out of 100, we would get a result somewhere in the range 39 to 64. That's what an MU range means. Okay? It's not, and you can see, it's not 50 plus or minus a figure. The difference between 50 and 39 is less than the distance between 50 and 64. It's actually weighted a little bit to the high. It's not smack in the middle. It's just, it actually converts to a log, and we adding a log either side. But that's what an MU range is. So when you get a result of 50 for that particular test in our laboratory, we will tell you the range for that result is 39 to 64. So if we took that sample and tested 100 times, those results 95 times out of 100, you get a result somewhere between those two. Okay? So how do you interpret regulatory guidelines such as AS3666, which is the Legionella, Australian Drinking Water Guidelines, the Food Standards Code, all of those things, recreational water standards, all this, at this stage haven't caught up and said how you interpret an MU, which is just ridiculous because we've been told we have to report it, but there's no documentation telling you how you're going to interpret these results. What we recommend, and so does NATA, is that we go via these guidelines from CITAP Guide, and we can send you that that link if you want to get through to us. But that's how it looks. Okay. And this diagram actually comes from that the CITAP Guide. Describes the relationship between MU and pass-fail to a specification. It should be noted that the true value, which is the true value of a sample, can occur anywhere in that MU range. If I give you a result of 50, that doesn't make it the true result. What it says is the true result is anywhere in that range. Okay? So it can be anywhere. And so let's look at, now we'll look at some test results where, let's say the acceptable limit is 100. That's what that line represents. Okay, that's a level of 100. Okay, let's look at the first case. I give you a result of 210. That's got an MU range of 160 to 270. That's easy, that's a no-brainer. Look at the bottom end of the MU, 160. That's still above 100. That's a blatant fail. No problem, easy to interpret. And now, all of a sudden, for a lot of you, you've just realised where the painful part of MU reporting is, haven't you? Those ones. Let's go to the next example. I give you a result of 50. Remember, the acceptable limit's 100. What was the MU range for 50? 39 to 64. Again, no problem. That's a pass. Look at the upper limit of the MU, 64. That's still below a fail level. So that's a pass, no problem. Now we have problems. I'm going to give you a result of 110. That's a fail. Acceptable limit's 100. MU range is 86 to 140. Anywhere in that thing. Is that a fail? Or is it a pass? Give you a result of 90, that's a pass. 90, that's acceptable, no problem. MU range is 120 to 70. Is that a pass? Or is it a fail? And what they do state is that obviously for case 2 and case 3, it's your decision based on risk analysis to accept the result as a pass or fail. Obviously, case 2 is more likely to have a true result that's a fail, that is case 3. Doesn't it? Because that thing, but it can appear anywhere in that range. At present, Australian authorities haven't stipulated how to use the MU. Are they going to say if any part of the MU is under the level, it's regarded as a pass? If it's a fail, it's going to be a fail. All they've said is you have to perform a risk analysis based on what you get. And until that's written into those food standards code, we're required to report it, and we must get laboratories to report it, and I'll show you why very soon. But it's up to you to determine how you're going to do it. If you're going to say, until that comes out, we're going to ignore the MU range and we're going to work off the actual result, that's fine. As long as you can as long as you can justify the quality side of that and the risk, then that's fine. What's your answer to that question? By the regulations, the count of 90, that's a pass. You can sell that to a healthcare facility. Are you going to? You've got to make that decision.
The individual has to make that decision.
The company has an individual or the company until these guys come out. And that's part of the issue. Is that looking at your target, what's your shelf life, what's your thing, how's this, I'm selling it to miners as they're coming out for a lunch break from Mount Isa Mines. I would take 500 as an acceptable limit for staff. But I'm selling it, to the local nursing home. And that's a 25% past the end of the shelf life, had a count of 90. I'm really going to be happy, are you going to be comfortable with that? And you're going to be able to justify it when someone gets sick. And certainly at the moment, it must be realised that interpretive reporting on laboratory reports at the moment is solely based on the actual result, not on the MU range. As I say, it's your decision on how to interpret the MU range. Make sure your provider of laboratory services is at least giving you the information so that you can make these calls. You're paying for the service, make sure you get the information that's necessary and all the results. Here's a perfect example of why you need MU. These acceptable limits over here. Here's your results, and you'll note yeast and mould, there's no interpretation because there is no guidelines for acceptable results. Everyone happy? All ticks, all less than the acceptable limit. How about now? On 3 of those tests, their upper MU is a fail of the food standards code. You're still going to think that's a totally acceptable product when 3 of those tests, which it counts, have all failed by their upper limit. Do you look at that differently? Even with one line, you're looking differently. Do you see what I mean? Yeah. There's good information to get by having these MU results. We had a customer who had everything passed, and I think it was a Bacillus cereus count. Not one of these. A Bacillus count of 100. The MU range was 60 to or less than 100, up to 120 or whatever. What they did was they went back and in fact tested 5 more products. Each, because that MU range was all under, every one of those 5 products came back with a Bacillus cereus count of less than 100. They then justified it with the environmental health officers that they'd taken 6 samples and one was a count of 100, the other 5 were less than less than 100, therefore the average count was certainly less than 100. Health department agreed with them and they sold the product. They kept monitoring it throughout their fairly short shelf life. It was never detected again. So there actually can be economic, rather than dumping for these guys, which was a lot of product and a lot of big cost associated with it. They actually were able to prove, because of the MU range and their further testing, that in fact it was a safe product. You know, bugs are not evenly distributed throughout a food matrix. We can find that one colony of Clostridium perfringens or staph or whatever, and because our limit of detection is 100, one is immediately a fail. So, you know, you have to realise multiple sampling can in fact justify that in fact this bug is not evenly distributed, and we just picked up that one bit, which could have been come off a person's hand or whatever, but it doesn't matter. Okay, so can be cost savings.